Here we go with the last example for optimization. You can follow along. There's a textbook example about finding the surface area of an aluminum can that makes the cost as small as possible. This problem is similar, except we're told in this case that there is waste that comes from cutting out the tops of the can that we have to take into account. So, important facts: we know that we want to design a 1,000 cubic centimeter right cylindrical can. We know that the area, the surface area of the materials we're going to need altogether is right there. And we want to know what is the ratio of H to R for the most economical can. Economical means here that uses the least surface area, because that means uses the least materials. So now I've got my answer to question 1. What do I want to optimize? I want to minimize the area, minimize the surface area, and that was nice. They actually gave me a formula. So my next step is to write the A function as a function of one variable, but notice I have this problem. I have both R's and H's. So just like that second example we did, we have to go off on the side a little bit and find a way to rewrite H in terms of R so I can make a substitution in, and I don't end up using two variables in my equation. Well, what's one thing we know? We know the volume of a cylinder is pi r squared h. You did know that, right? And we've been told that the volume of this cylinder has to be 1,000. So we know 1,000 is pi r squared h. I can take that equation and solve it for h. So I get 1,000 over pi r squared equals h, and I'm going to make a substitution in of this value for h. So once I've made that substitution in, I've got a new expression for A, the value I'm trying to minimize, and I can proceed. So what do I need? I need the derivative of A so I can find any critical points, and then I'm going to start my table of values. I'm going to move the whiteboard slide and start over. Now I'm looking for critical points. That's any place that A prime equals 0 or is undefined. I can see that A prime is going to be undefined when R is 0, but I wasn't going to have a radius of 0 for my can anyway. So I'm going to proceed. I've got 2,000 over R squared equals 16R. I can get 2,000 over 16 equals R cubed. Take the cube root of both sides, and I come up with R is 5. You didn't think it was going to be that easy, did you? All right, I know I want to make the radius of my aluminum can 5 centimeters. I got to figure out now what the height of the same can is going to be. So I'm going to use that same formula I had for height a second ago. Height is 1,000 over pi r squared. So that's going to be 1,000 over pi times r squared, in this case, is 25. And I get 40 over pi. I've got one more step. I was asked to find the ratio of H to R. Ratio just means fraction. So I'm going to make a fraction out of H, which was 40 over pi, over R, which was 5. I can simplify that. That's 40 over pi times 1/5. Which makes 8 over pi. You can check that that's the answer in the back of your book.